So this is a optimization question under a constraint, which means we have to use the Lagrange multiplier. Lagrange multiplier means we're making use of this formula. Therefore, we need to calculate the gradient of each. Gradient of f is, well, gradient is just writing down all the partial derivatives you can write and making a vector out of it, right? And then when you differentiate this by x, that means you're treating y and 6 as a constant, right? And whenever you have a constant multiplication, constant multiples can be brought outside the derivative. Yeah. Everyone knows this if you passed Calc 1, except that some people don't know that they know, okay? Yeah. So just remind yourself that if you have a constant that's multiplied inside the derivative, you can pull it outside the derivative, right? And then derivative of x is 1, so you get 6y as f differentiated by x. In the same way, if you differentiate 6xy, where this time this prime means differentiate by y, treating x as a constant, that means 6x is a constant multiple, you bring that outside and you're just differentiating y, which gives you 6x. So that's what you get as the x component of the, that's what you get as the gradient of f. Now gradient of g, well, g here means the left side or right side, whatever, one side of the constraint, where the other side has to be a number, okay? If this is not a number, then you have to move all the variables to one side so that the other side becomes a number, okay? All right, so we're considering this as our g, and when you differentiate this by x, that means you're treating y as a constant. So we're differentiating x squared over 9 plus y squared over 4. But because this is a constant, constant over constant is a constant. So when you differentiate a constant, it gives you 0. And therefore, this just gives you 2x over 9. And in the same way, if you now treat x as a constant and then y as the variable you're trying to differentiate with, then y squared differentiates to 2y. There's 2y over 4, or you can also simplify this as 1/2 y. Now we take these two and plug it in here. So 6y, 6x is equal to lambda times 2 over 9x, 1/2 y. And that translates to two equations because lambda gets multiplied to each one of them. You get 6y equals to 2 over 9 lambda x, and 6x equals to 1/2 times lambda y. How many unknowns do you have? 3. What are those unknowns? X, y, lambda. How many equations are these? 2. So we're missing one more. Where do we get the other last one? Yes, the constraint. So x squared over 9 plus y squared over 4 equals to 1. Together they form a system of 3 unknowns and 3 equations, which is good. Okay. Now, in all of these, you need to solve for one and plug into the other, right? So you're going to take this and solve for y by dividing by 6. So that's going to be 1 over 27 lambda x. Because you can divide both sides by 2, And then you can divide both sides by 3, and that's what you get. Okay? Once you have that, that's going to go into each of the y's, and let's see what that gives us. We get 6x equals to 1 over 54 lambda squared of x. So that's what we got from here. Different color. This one gives us that. Now, what does that mean? Well, that means two things. If I multiply by 54 both sides, then you get 324x equals to lambda squared x. I like to do this because I don't like using fractions, so I just multiply 54 both sides. Okay? And then you move this to the other side, so you get 0 equals to lambda squared x minus 324x. And that is you can factor an x out, right? You can factor an x out, and what that means is you get lambda squared minus 324. And therefore, either x is 0, or lambda squared minus 324 is 0, and that means lambda is plus minus square root of 324. Now we can further simplify this, but let's leave it at that. Let's think about what happens when x is 0. If x is 0, what's y? If x is 0, y is also 0, right? Then what happens here? It's false. It's false. 0 squared plus 0 squared cannot be equal to 1. There's no way, right? So sometimes that happens. Like I showed you different examples last time where like solving a single equation like this will give you different cases, and each case gave us some numbers, and among them we have to make a judgment of which one is the maximum or minimum. This one gives you an answer where if you track it, so x equal to 0 leads to y equals to 0, and then x squared over 9 plus y squared over 4 cannot be equals to 1, so this doesn't work. This case doesn't work. On the other hand, let's see, 324, that's what, 18? Yeah. So lambda is equal to plus or minus 18. That's what this gives you, right? Square root of 324 is 18. Come on, somebody check. Yeah. Okay, good. All right, so you have still two cases, positive 18 and negative 18, right? So let's try two cases. So this will be case 0, which didn't work. Then case 1, lambda equals to 18. If I take that and plug it back in here, we get y is equal to 1 over 27 times 18x. And therefore, when you, they're both divisible by 9, so if you simplify further, you get y equals to 2/3 x. And that goes into here. And if that goes in here, you get x squared over 9 plus 2/3 x squared over 4 equals to 1. And that simplifies to 2/9 of x squared equals to 1, so that x is equal to 9 over 2. X squared is 9 over 2. If you flip to the other side, and you get x equals to plus minus 3 over square root of 2. I just realized this gets squared anyway, so let's just handle the plus minus together. So plus minus together, this will have plus or minus, and you still get the same thing. And then because y is 2/3 of x, that means y is equals to 2/3 times, or plus minus, 2/3 times 3 over square root of 2, and 3 and 3 cancel, so you have 2 over square root of 2. Okay, so what does that mean? That means points that satisfy the Lagrange equations are points that satisfy gradient of f equals to lambda times gradient of g are, there are several points. There's the 3 over square root of 2, comma 2 over square root of 2. You could also have negative 3 over square root of 2, comma 2 over square root of 2. Positive 3 over square root of 2, but this time negative 2 over square root of 2. And then both negative. Okay. So these are all the possible values of x and y that would satisfy the equation. Lagrange, yes?
Is 2 over square root of 2 just square root of 2?
That's true. If you rationalize the denominator by multiplying square root of 2 top and bottom, gives you that. So if you want, you can simplify it further. But that's not necessary because we're looking for 6xy, right? So if you multiply, the bottom gets squared and it gets simplified anyways.
Okay.
So then f of xy is going to be what? 6 times plus or minus 3 over radical 2 times plus or minus 2 over radical 2. I'm just doing all 4 cases at once, okay? So it could be plus, 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 minus, minus, plus, minus, minus. It's these with different signs, and could be plus, 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 minus, minus, plus, or minus, minus. So it's either plus or minus of 6 times, 3 times 2 is 6 on top, and then square root of 2 times square root of 2 gives you 2 on the bottom. So you get plus or minus 18. Because 6 over 2 is 3, 3 times 6 is 18. And then what is plus minus 18? Well, those are the value of this function at the Lagrangian points. So the maximum would be 18. So this one cannot grow so big. So last time we also had an example where x and y could grow to be very big so that you didn't have a maximum. Yes, so that could happen. But here, what's the graph of this? This is it's a ellipse with a longer radius being 3 and then the shorter radius being the 2, right? 3 squared and 2 squared. So at maximum, x is 3 and negative 3. X is between 3 and negative 3, and y is between negative 2 and positive 2. And therefore, this cannot have like an infinity or negative infinity as a possible value. That never happens. So because of that, the max and min has to be from these. And of course, 18 is bigger than negative 18. So the answer is max is positive 18 and min is negative 18. Now, if you also need to specify the location where this happens, positive 18 happens from on here and then there. Those are the 2 cases when you get the positive. Negative 18 happens here and there. So That could also be a question that you have to answer. Yeah.